All right, this is the second video for section 2 of chapter 7. We have another allele interaction to deal with. We're doing codominance this time. And codominance, the main example that we're going to use for this is blood type in humans. So first you have to recall that there are 4 different blood types. You have type A, you have type B, you actually can have type AB, which is that codominant. A is dominant, B is dominant. When you have both of those together, that blood type AB is what you have. And then finally, you have that recessive blood type that's type O. So we're going to use different alleles to represent those traits. There's an A allele, a B allele, and an O allele. All of those things come together to make your blood type. So we're going to do kind of a weird Punnett square here to come up with all the different possibilities. We're actually going to do 3 alleles in this Punnett square, 3 by 3, which is kind of weird. But we need to have that A, B, and I is going to represent O, mostly because the lowercase o is kind of hard for me to draw, right, or represent very easily. So we're going to fill in this square just to see all the different possibilities. You could be homozygous for A. You could have an A and a B, and that make you type AB. You have an A and an I. That would make you type A, because O is recessive. That lowercase I makes it a recessive trait. So if you have A and I together, you're type A. Here's another AB. If you're homozygous for B, that makes you type B. BI would be type B. AI again is type A. BI again is type B. The only way that you can be type O is if you have 2 recessive alleles for that blood type O. That lowercase I is going to represent that O trait. So throughout this Punnett square, you see the different possibilities. AA is for type A. Let's use green for type A's here. AI is also type A. So 3 out of those 9 possibilities are for type A. If I use yellow for B, these 3, BB and BIs, are going to be for that blood type B. AB is when you have A and B together. And then again, type O, the only way that's going to show up is if you have those 2 recessive alleles. So this one's a little bit more complicated to look at. This wasn't a cross between 2 parents. I'm just trying to see all these different possibilities. But the codominance is when both traits are present at the same time. So when you had that allele for A and B, both traits, both markers on those blood cells show up. And so it's codominance. A is not dominant to B, B is not dominant to A. If you have both of those alleles, both traits show up. The other part of blood types that we need to understand as well is the RH factor. That RH factor is either positive or negative. So you could be A positive, you could be A negative. But that RH factor only has 2 different alleles. It's either positive or it's going to be negative. Positive happens to be dominant to negative. So if you're heterozygous for those 2 things, it's going to be a positive RH value. So again, we can do kind of a hybrid cross here, right? Plus minus, cross those things. We should see all the different possibilities. So you might have 2 positive alleles. You might have a positive and a negative down bottom left as well, or a negative and a negative. So the only possibilities here are to be positive or negative positive is going to show up when you're homozygous for that trait, but also when you're heterozygous because positive is dominant. Whereas the only way you could be negative is if you have those two recessive alleles for that negative Rh factor. So this slide is just trying to put together all those different possibilities. We need to be able to apply that. So we're going to do this example here. What is the probability of an offspring having type A positive blood if the parents are AB positive, heterozygous for that trait, and also O negative? So I have to do two Punnett squares to get this answer. The first Punnett square is just going to be for those alleles, for A, B, and O. And so one parent is AB, so they have an A and a B allele. The other parent is type O, so they're going to have those two recessive alleles. And we're using I still instead of O because it's just easier to see that it's lowercase. But then you cross and you get these different possibilities. But you also need to deal with the Rh factor so you can find out what that's going to be. Since it said that the AB positive was heterozygous, I'm going to assume that that person has a plus and a minus, has both the dominant and recessive allele. Whereas if that other parent is negative, you know they have to have two negative alleles. So I'm going to cross that separately. And then I'm going to use these two Punnett squares to come up with my answer. I want to know what the probability of having an offspring with type A positive blood is. So I have to look at both Punnett squares to get this answer. In the first Punnett square with the letter type, the two offspring on the left are going to be A, the ones on the right are going to be B. So the probability of being that type A is going to be 1/2. The second Punnett square for the Rh factor needs to be positive for that offspring that I'm looking for. I wanted A positive, and positive only is going to occur in this case when you're that heterozygous on the left over there, but again, the probability is going to be 1/2. Now, I used two different Punnett squares and I need to combine those probabilities. I can't just add them together and say that 100% of my offspring are going to be A positive. I can't just leave it the way it is because half of them aren't going to be A positive either. What you need to do when you're combining two different parts of this together is you need to multiply those two fractions, 1/2 times the other half, and that's going to give you a 1/4 probability of having that A positive blood type. So again, you do the letter type and the Rh factor separately, combine those two probabilities by multiplying, and that'll give you your probability for whatever type it is that you're looking for.